Okay, let's begin there. Let's see if we can successfully stream the whole session today. It feels like my computer is starting to give up, or I'm pretty sure it's the power supply. It can't seem to... When we get energy spikes for the graphics card, it seems like the power supply can't give it enough power, and the graphic cards either times out, or whatever process called for the GPU to do the work times out. Sucks. It has been like this. I've had similar issues in the past while doing heavy renders in Blender, and ever since I switched to Unity 6, which I've heard is more graphic card intensive, I've also started to see this issue while using Unity, and this fucking sucks. Luckily, I was given a computer that is a tiny bit better than the one I have, so I'm gonna try and switch these. I don't know if I have the time this week, but maybe to next week. Anyway, we'll just try to raw dog this and see if we can get it over the finish line. Because honestly, yeah, I'm super fine currently in holidays. Oh, nice. Nice. Good morning, Geralt. Hope you had a wonderful weekend as well. So, I haven't had that much time to research this weekend. It's been hectic. So I'm thinking we're gonna do a lot of the research today. So it's pretty much gonna be like, so when you write a thesis, you have one section at the start where you have where current work is, like and that's it's pretty much that part we're going to do today. So we're going to do some research about tessellation and how to best implement it, both visually and performance-wise. I'm going to try to define our problem as well. Because once again, I have to say, like, tessellation, a simple tessellation implementation that gives acceptable result. We are already at that point. It's just that I want to push it a bit further, because the end goal is to utilize this tessellation in both the snow, both the ground terrain, and for the water. And in this scene right now, I think we have a great example of the parts I don't like at all with this tessellation, or with the tessellation. And it's mostly these points. They are extremely visible, and they don't help to sell the visuals of it. This is much better. So what it all stems from is, here we can see that the displacement is aligned with the split into triangles. Here we can see that it's the opposite, and that's why you get these jagged edges, which I absolutely hate. So I actually reopened this issue, which is a very old issue, and renamed it a bit. So instead of just being implement util tessellation, so I was thinking implementing it like a library file that we can include in all shaders that needs to tessellate in some way. That would be the, if we can put it in such a library file eventually, that would be the best case. But we're gonna have to find out if we can do that, because it might be, each shader might need to send on very specific data, and if so, we can't really do it in such a general way. So this issue is more on just getting proper tessellation, optimal in both performance and visual fidelity, you know. During the tiny bit of research I did this weekend, I found something that I've mentioned previously, but I've heard about it for a long while. It's been bubbling in the graphical community for a while, I suppose, and it's something called mesh shader. I'm just going to take this one. I'm going to link it in the Twitch chat. I want to link it in the YouTube chat as well. One sec. It's something that I definitely believe in, and I think this is going to be amazing. So the gist of it is pretty much the geometry part of the graphical pipeline, so vector shader and possible tessellation and geometry shader, they are not really implemented in the best way possible for today's hardware. So instead, we have started seeing a shift towards replacing those three shaders with something called, or those three stages with something called mesh shaders. And I think they also have there's supposed an amplification shader as well. So amplification shader and mesh shader will possibly in the future, probably, replace vector, tessellation, and geometry shader. And basically when it comes down to it, mesh shader is pretty much just, it's very similar to compute shader, except it has the possibility to return primitives like triangles and stuff like this. As far as I've understood, this would 100% solve our issue. We would have much more control here if we would like to do quad flipping or whatnot. The only downside with this one, what I've found, is that you need DirectX 12, and if you don't want this to be, and then you need like a graphic cards that support some of the things this one does. If you don't, and you implement it as a mesh shader, either way, you're gonna get, it's gonna simulate it, and it's gonna cost extremely much or a lot in performance. So basically, if we choose to go this path, which I would love to, but if we do, we're gonna exclude a lot of graphics cards. And that's pretty much the only thing that's holding me from this one. But this is like a last resort kind of thing. So what I want to do here is I want to define our problem, some of the possible fixes we can imagine right now, and see what we can do about it. I have one approach I believe in the most, and that would actually be to go back to triangles, and instead of splitting quads into 2 triangles, we split quads into 4 triangles. So that would pretty much be, instead of having like this, we split it like this as well. And I would like to define this in this issue here. I don't know how well we're going to do it with graphical, but we can probably do it with so if we would do, one sec. We could probably get around it by doing something like... Don't I have an ASCII? ASCII symbols. Unicode characters. Here we... Or is it Unicode? I'm gonna go real old school with these graphical... Yeah, we can probably find it here. Raise the amount of symbols, but I'm wondering if we can do something like... Circle, is that big enough? Like, I'm wondering if we can explain it with symbols like this. Then we're gonna get this. It's probably better if we do it... Just import some images. But let's do them the right way this time. Or if we should just bring it into like draw IO, might be an even better option. Yeah, let's see what we have. What do we have here? Do we have dark mode for this one? Appearance dark. Beautiful. Okay, let's do it like this. Beautiful. Okay. So this is basically what we're working with initially. At some stage, so we have chosen quads because they tessellate in such a good way. If we do tessellation 2 to the power of x, we always get tessellation like this. Let's see. Wonder if we can mark these. Then we can put it in the middle. Okay. Oops. So if we work with quads like we do now, and we tessellate it to 2 to the power of x, we always get something nice like this. So it's extremely easy to identify new vertices, right? Which means if we identify the new vertices, we can adjust the height of them depending on view, and we can reduce hopping a lot. But the main issue is that at some point we're always going to see triangulation. So we can either get a triangle like this, or we can get a triangle like this, or triangulation. And this is where our problems start to appear. What I would like for us to produce the best possible visual fidelity while doing displacement based on terrain and stuff like that, I would like to have control here over how we triangulate stuff, but control triangulation during tessellation. We have this one, and during our trial and error, we found this answer to be quite correct. So exactly how triangulation happens in tessellation is largely implementation defined. Right? So we don't have that much control during the tessellation. Like, we just define how much should we tessellate this and where should we tessellate this. How the triangulation happens is most likely up to the implementation, which implies to me that it can also vary between hardware. And that sucks. But this one definitely belongs in our references here. Stack Overflow. Triangulation during tessellation. Most likely find. So yeah, sure, this is one thing that sucks for our use case. Okay, so we can't control it during tessellation, but we can control it in the geometry shader. So that would pretty much leave us at a point where we implement tessellation, and then we let the tessellation part of the shader generate some new points for us, and then how these points consist together, or how they are connected, we solve in the geometry shader. Geometry shader, however, quite a performance hogger. It will degrade the performance quite a lot, but we could solve it here with some magic. It would have been way easier for us as well if the geometry shader could take more than 3 points. So that's the next issue we ran into. So let's jump to HLSL geometry shader. Geometry shaders can take point, line, line adjacent, triangle, triangle adjacent. We want at least 4 points, basically. So we could possibly lean towards using line adjacent or triangle adjacent. However, let's see if I can find this one again. HSL tessellation shader. I think we had it there. A geometry shader that expects primitives with adjacency is not valid when tessellation is active. So can't use this, can't use this. So these are things we ran into last week. I'm just going through them again, and I want to put them in the issue. Like, so we have that information collected here. We're probably gonna write it out in text eventually as well, make it a little bit nicer. And what do we have here? Let's just call it HLSL documentation. Geometry shader. Y J states that adjacency Okay, so back to this one. We're pretty much in a state where we can't use tessellate and do quad flipping or decide how it triangulizes without an extreme performance loss by implementing a geometry shader that creates duplicates of points and stuff like that. So what I'm wondering, what I hope will be the answer to, or our solution, our eventual solution, is that we move away once again. So we have pretty much gone from working with the triangle mesh to working with a quad mesh, and now I'm thinking about reintroducing the triangles, and that's because I want to define a mesh that basically it consists of a lot of quads that looks like this. If let's see, so let's show some examples. One sort of tessellation we see a lot, at least with this hardware and the current implementation, is something like looks like this. So we split it at the center of it. So these three are all examples of what we possibly end up with in its current state. But if we could create and work with a mesh that looks like this, yeah, sure, we would see 2 additional triangles per quad, but the smoothness of it would be way better. And if we take a look at, actually, I want to just grade this one out as well. Okay, so if we work with this, if we have this topology, we're going to have to rely on doing tessellation on triangles, and it's a little bit harder to foresee exactly how they split, but if we could manage to get something like, actually, let's delete this one and just start with this one. If we could get a triangulation that looks like and let's see, probably want to put it here. Something like that. We have the correct color here. I think so. Not entirely correct, but yeah, let's do it like this. Come on. Okay, there we go. If we could get triangulation that looks like this, it would be perfect. Most important part here is that so what I'm looking at here is, so if we work with a mesh of triangles, so when we send it down to the GPU, we state that the topology here is triangles, and then we do tessellation on it. Instead of you working with nice UV coordinates to interpolate the new points, we're going to have to work with barycentric coordinates. And I've been down this route before, although I have much more knowledge now, so hopefully we can manage. But like, if we take a look at the new points we get here, the gray points, it's basically located at, so barycentric coordinate 0, 0.5, 0.5. And what is it? Yeah, we're gonna have to figure out the exact way. But like, what I'm worried about here is if we have the possibility to identify the new points here with good precision, such that we can solve the popping issue, even though we go with something like this. So that's going to be the first issue. The more I look at the topology of this type of quad, or quad splitting, or yeah, the more optimistic I get. This type of topology, I think we need a... There's supposed to be a point there as well, yes. So... these points right here are actually not new during this tessellation. So for each tessellation stage or iteration, we would like to, so per quad, we would like to see 8 new points. And we're gonna have to do, I wonder how we want to do it when we calculate the normals here. But that's possibly a later problem. So previously, let's say here, for instance, when we calculate the normal for this point, we have 2 approaches. One is a little bit smoother than the other, but our default approach is to take all connected vertices. So we're talking about this, 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 and this. And then we also have one that takes 2 additional points into account, and it's this point and this point. And here's another problem concerning the topology we create, because we can see here that this one and this one, they are not connected to this one. So when we displace this topology and we use all the neighboring points to calculate the normal, we're going to see a little bit of a mismatch between the normal we have calculated and the actual bend of the mesh. If we would go with this topology, and we successfully end up at this type of tessellation, and we decide to only base the normal of the connected nodes, we can see here that we get down to 4 neighbors that we base the normal on. It's going to be all the neighboring nodes, but that's just the original. If we take a look at this one, when we have tessellated once, we can see here that this one only has 4 connected neighbors. This one has an additional 2 connected neighbors. The problem being that these two are located further away than these four, I would say. So if we go with this solution, the normal calculation is going to be a little bit weirder, but hopefully, like, if we can uniformly tessellate it like this for each iteration. So what it comes down to is we want to do this Zelda-like pattern, Triforce-like pattern for every tessellation here. If we can manage to control it in such a way that that's the tessellation we get, then we have all the information we need to properly calculate the normals as well. But if it's one thing I've learned during this tessellation adventure, it's that it's extremely dangerous to do those types of assumptions too early, because we're probably going to run into a problem where, yeah, we can't go that route. But 100%, I have a lot of trust in this one. Okay, so what I think I'm gonna do now, the course of action, is that we're gonna create a new monobehavior script. Let's generate a mesh. I know that we already have one that generates it in a quad-like fashion. I want to start fresh. Keep that one, because, like, this is just a new... This is like a different way of doing it. We're gonna see if it works. If it doesn't work, I still want to revert back to what we have working, and I guess I'm just gonna have to live with the visual artifacts we get from splitting it like this. Yeah, what's up, Arya? Creatures are squares. We're probably gonna have some square-like monsters, but these are not creatures. Hopefully I'm gonna be a little bit more creative with the creatures than this. Okay, so we're gonna implement the monobehavior script that from the beginning gives us we define how big of a patch it is, how many subdivisions we want, and we create a triangular mesh just like this. And then we add some tessellation stages to it, and we can experiment with it and see if we can end up with something like this. To reduce the chance for a crash or a GPU timeout, we're going to do this. We are going to create a new scene where we do our tessellation experimentation. New scene, tessellation experiment scene. Oh, it's been a while since I've seen these colors, but okay. we can also do, yeah, this time around we can do settings, rendering, renderer. Let's just disable these two. Beautiful. And then we do scripts. We're gonna do misc temps. Yeah, let's put it here. I'm gonna behavior script, and we're gonna call this one you know, it won't be a bad game to have game that's just shapes as creatures you can collect. That's true. Some players have very good imagination. I'm just thinking about the old school RPGs that were... Ah, fuck. Dwarf Fortress, the original one. Fucking beautiful. Simplistic, but descriptive. I want to create... Yeah, let's create an empty tessellation mesh creation. Let's put it at 0. If we take a look at this one again, Arias, what you're making actually. I'm also a big fan of simple games, definitely. Although I've been starting to be worn out by... We had some years, around 2017 maybe, where you had these hyper-casual games that were extremely simplistic in design. I'm kind of worn out there on that type of those type of visuals. So what we're working on today is we're implementing proper tessellation. We've been trying to for the last week. I want to do it in such a way that we get the best performance and best visual fidelity. So what we're looking at here is different ways we can build up the mesh of the objects we want to displace and tessellate. So this is mostly going to be environment, water, snow. We have been doing an approach where we go with quads and tessellate them like this. But at some point we need to triangleize them. So we either get this and this, sometimes we get this, sometimes we get this, sometimes we get this. To get the best possible visual fidelity, we want to control how something triangulizes, because we want to align it with the slope. Unfortunately, if we use tessellation shaders, we don't have control over that. So now we're gonna experiment by having a base mesh that looks like this. Triangles the whole way through. Hopefully we can implement a tessellation stage that tessellates it perfectly like this. Ari, can I share a game? Playing it lately? Yeah, sure. Go ahead. Okay, so we're going to start by creating the script, the mono behavior script that creates this shit. I'm just thinking how when we create a mesh like this, it's extremely easy to create the triangles and such. This is also quite simple, but prime side. I'm gonna take a look at it after the stream. So I'm wondering if we just want to define these points first and then we define the center points. But I wonder how weird that would be. Mm-hmm. 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 I don't think this will have any effect on the performance of it. So basically what we do is we create a list of vertices. Maybe. I wonder if you want neighboring vertices in that list. Depends on how big it is, probably. Maybe we want to define it like uh. Yeah, you probably want connected vertices. Wonder. So one thing we could do is we calculate these points first. So just old school quad-like points. And then at the end of the vertex list, we put these. And then when we do the triangles, it's going to be this one. All right. Thank you for stopping by. Good luck with work. I don't think it should have any effect on the tessellation later on. Okay, I'm thinking we start by this, and then if row number is greater than 1, we do these. So for first row, we don't do these. So for this one, then we do this, and this. And then this and this. Is that weird? Nah, best case would probably be to go... If we can create a for loop that goes... Yeah, okay, let's do it like this. So... the idea is that subdivision amount 0, 1, so on. So is how many times we subdivide the big edges. So like basically subdivision amount 0, then we just get one edge. Subdivision 1, we get 2 edges. Subdivision amount 2, we get 4 edges, and so on. So yeah, we're just gonna say subdivision, because what I want to do is generate mesh, mention, then we do mathf.pow to the power of subdivision amount. And I guess mathf round to int. So here we get 1, 2, 4, 8, 16, and on and on and on. So vector 3 positions. No. Vertices. Okay, so as for the size, if we just ignore the middle point right now and we do size, if we have a subdivision of 1, get 2 times 2. So I guess we want to do subdivision plus 1 times subdivision plus 1. Yes. So for 0 here, we would get... it's not entirely true. And we would never get 0 here. This one can be 0, but not this one. So we would get 1. So 2 times 2, 4. That's our 4 points. If we have subdivision 1, we get 2 here. So 3 times 3, 9. 1, 2, 3, 4, 5, 6, 9. But we haven't taken these into account. Here we have 4. Here we have 1. So plus, can do plus, and how do we want to solve this? My concern is I came back to triangle tessellation recently and found out precision is equal to 1 divided by 3 times 2 to the power of n, at least for a specific tessellation I tried. And n in this case is the tessellation amount. That can be nice to keep around. 1, 4. I wonder if we're always gonna get... I wonder if we can change this one to be... I wonder if this one can be math f how not dimension, but subdivision plus 1, 2 plus wonder if we can get around by this. Subdivision plus 1 times itself. So this one right here is the outer vertices, then we have the inside. So in this case, we would get subdivision 0. So 0 to the power of 2 is 1, we get 1 extra. For this one, we would get... we have a subdivision of 1, so we get 2, so we get... No, for the first one, we have 1 here, yeah. Then we have 2, so we get 3 times 3, that's 9, and then we get 2, so 4. That should hold, this should hold for no matter how far up we go. And then I'm wondering if we're gonna do do we want to have these separate? Yeah, we do. So basically, oh, I wonder if we want to do no, it's gonna be the same for both sides. We don't really care about that. But I'm wondering if we want to do vertex count in 1 dimension. So we skip the POW. So we basically just do this. So for a subdivision of amount of 0, we get 1 here, so we get 2, 3. Here we get 3 as well. Subdivision 2, we get 3, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. But. It's like we want to loop through whole numbers 1, 2, 1, 2, but we also want to do 0.5 every other loop. I don't know if we can do this in one loop, so it's gonna be like one, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Nine, 13, yeah. So basically want to go I wonder if keeping track of this one would be the easiest. And then we loop through. We decided more on we do outer subdivision, so 0, 0.5, 1, but we loop with a step size of 0.5. We don't want to go all the way. Wouldn't that be okay? 0, 5. Then we'd want to jump 1 here. We can do a simple solution. The simplest way would probably be to generate these vertices first in a nested for loop, and then we generate these vertices in an additional nested for loop. Think. Outer vertex count. And then we can do like this. -1, I reckon. So let's see, subdivision. I want to double check this so a lot right now, so we don't have to, or so we can minimize the risk for out of bounds errors later on. This is subdivision 1, subdivision amount 1, so we get send down a 2. So 2 here, so we get outer vertex count 3. So here we get 3 times 3, 9, 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. No. We want start to be this one. So then we start at 9. This one should be correct. Yeah, something like this. And then we do I think I want to do floats here. X is equal to 0.0. X is less than or equal to 1.0 f. Plus equals to 1.0 f divided by outer vertex count. So outer vertex count is 3 here. So we want to do -1. So 2. So we get we could probably do this. So in this case, we get subdivision. We do 1. We get 2. This one is 3. So we get 2 here. So we get 0. 1 divided by 2, 0.5. So we do 0, 0.5, 1.0. Yes. And then float y is equal to 0.0 f. Y is less than equal to 0. Y plus equals to outer vertex delta. Megazones, oops, I took my time to answer, but my precision, I mean that doing model that precision with a specific n. Exactly, that's what we've been doing as well, but the specific tessellation I tried is oriented, which you don't want because of the slope. Yeah, that's exactly the problem we're having. Like, we want control over the slope, and that's why we're trying this topology instead, because then we don't need to care about orientation. The backside being that we're gonna tessellate by triangles instead of quads. And I do like to tessellate by quads. And then what we can do here is, by doing it like this, we will have a nice... we can generate some nice UVs later on as well, but let's do vertices. Vertex index is equal to 3. We want to add a new here as well. We just want to do x times dimension x 0.0f y times dimension dot y. And then, of course, but now again, I'm doing it like, so now we're actually spawning it in, we're going this way. Rep, up, up. I want to go this way, so... yeah. We move x first, so we do da 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 da. And once again, these are only the outer ones, so this one, this one, this one, and so on. And then we want to do float inner vertex delta is equal to 1.0f divided by here. I think we want to do we want to have the same delta, I reckon, but we want to have a little bit of an offset. And the offset would be, am I doing this too complicated? Maybe. Outer vertex count plus inner vertex count. Outer vertex count 3. Inner vertex count 2. So we get 5. Minus 1. So then we get 0.25. 0.75. But offset, because what we want to do is we don't need to fix this one, I don't think. So we can do float y is equal to inner vertex offset. Y is less than or equal to 1.0f, I think. Y plus equals to outer vertex delta. index. So here we would start by doing the offset. So when we get to this one, we offset in y and x by inner vertex offset. But then for each step, we do outer vertex. So we would start with 0.25, then we add 0.5. So we get 0.75, and then we add 0.5. We're way above 1. I think we can do this just to simplify it a bit. And we want to do the exact same thing here. The hard part here now is going to be when we do the triangulation, when we define the triangle indices. We will probably start down here, go to this one, but not this one. So we're going to create them in a quad-like fashion. So for this iteration, we create this. And we jump to this one and we create this. Then we move on to this one. And then we move on to this one. Done. We can do it down here. So we do int triangles equal to new int sum size. Sum size. So we can pretty much do here, we can calculate how many quads we have, and then we just multiply that by 4 and 3, right? So one quad consists of 4 triangles, and each triangle consists of 3 indices. To calculate the quads, how many quads we have, we just do outer vertex count. Fuck it, just subdivision times subdivision times. So here we have a subdivision of we subdivide it once, subdivision amount is 1, this one is 2. So we have 2 times 2, which is 4. That's the number of quads we have. Each quad is 4 triangles. And each triangle is 3 indices, like this. And then we want to loop through, we want int triangle index is equal to 0. Then we do 4. We want to do this. So that is, this one is 1, 0, 1. Fuck it, subdivision again. Int, let's go I, let's go J. J is less than subdivision, J plus plus. Something like this, and then we're gonna do some magic in here. Is this correct? Subdivision is 2, 0, 1, and 0, or actually 0, 0, 1, 0, 0, 1, 1, 1. Okay, and then we do triangles, triangle index plus 0 Okay, hopefully these are created correctly, because we're gonna have to do... So I wonder if we want to start with this triangle, then this triangle, then this triangle, then this triangle. Yeah. Vertices. I wonder if I've screwed myself here. It should be something like this. J times, we're going to do it like this. J plus 0 times outer vertex count plus I plus 0. Ah, never mind. We're not gonna plot vertices like that. So like this. Outer vertex count is subdivision 2, 3. Zero. This one should be okay. So 1. We want to loop through these clockwise. So for this one, we want to go up here next, and then I wonder if we can just do this. This is going to be messy. Yo, what's up, DevSpiers? Thank you for the raid, appreciate it. Glad to see you're back streaming. And welcome to all the new viewers. Over on this stream, we're knee deep in some tessellation stuff. It's a long story, but we're creating a very specific mesh, and hopefully we can tessellate it in a very specific way to get the best performance and the best visual fidelity. That's pretty much it. Got runners off as usual. Yeah, it's to be expected, but thank you once again for raid, appreciate it, and you too. To summarize this tessellation issue in short, what's up, Dino, by the way? We have a solution working where we create a mesh that consists of quads. We then tessellate it so each quad becomes something like this. Works quite well. We know which vertices are new, which are old, so we can get rid of some popping. The problem comes with, so we're working with quads for as long as we can, but then we're going to get to a point where we need to triangulate these quads. We don't have any control over how they triangulate, so we can either get this or this. The problem is that we want to displace this mesh as well, so when we displace it, we want quads to be split in the direction of the slope, otherwise you're going to get extremely jagged results. Unfortunately, during tessellation, we don't have any control of triangulation direction. So instead, we're looking into a solution where we work with a mesh that is structured like this, i.e. we just add 2 triangles per quad. then we don't need to care about the direction of the slope. But if we work with something like this, we're going to get tessellation like this, and it's going to be a bit harder to figure out which vertices are new and which are old. But if we can figure that out, we're golden. Right now, we're just in the process of creating a mesh like this on the CPU, and then hopefully we can tessellate it. And Dino, if you wish, I can distract you in 2 weeks by providing you a link for my upcoming game jam. You're definitely free to provide it, and I will look into it after the stream. Unfortunately, I don't have much time these days. I think it's been like 2 years since I last entered a game jam. I do miss it. I do miss it. So here we're just creating a simple mesh that looks something like this, and we're just in creating the triangles here. So let's see. We want to create this triangle right here. So then we want to move up one here, and then we want this one. This one is going to be... so this one and this one is easy. 0, 0. And then we add 1 to y. But this one, so the third one, we're going to have to do something like... First of all, we're going to have to add an initial offset that is inner vertex start offset plus, and then we do j plus 0 . So by offsetting by inner vertex start, we get this one. We don't want to move up in j or I. So we do it like this. Is that all we need? Dino, this one is like 1 week long, but game can be done in 1 to 2 hours. Themes are like Snake or Tic-Tac-Toe. Very simple. Goal is to finish and share the code. And check others' code. Oh, I do like myself a open source game jam. They always lead to very interesting post-jam analyzing kind of stuff. So +1 to that. Also, I've learned a new word, tessellation. Yeah. The word tessellation is a word I've been repeating a lot for the last week and a half. If one would create a word cloud for my last streams, I would bet that tessellation is the biggest one, hands down. Okay, so usually when we create a simple mesh, or the way I usually do it is I create 2 triangles in every loop like this. This time around we're going to create 4. So next we're going to create this one. So j plus 1, first of all, I plus 0. We want to go clockwise, so we want to take this one next. So it's going to be j plus 1 still, I plus 1. And lastly, we want to take the inner one. So we go duh, duh, duh. The inner one, still this. And then we go on to the third one. I'm pretty sure we're going to get some out of bounds issues here, no matter how many times we look this over. But let's move on. So we want to create this one now. So I want to start with this one, then this one, then this one. So here it's j plus 1, I plus 1, j plus 1, I plus 1, and then j plus 0, I plus 1, and then it's this one again. And finally, we do this one. I wonder if we want to start with this one just to be, so this one is always the last one. Maybe that would be nice. So that is I plus 1, j plus 0. I plus 1, j plus 0, I plus 1, j plus 0, I plus 0. And this one is the same. The nice way of doing this is that this one will always be the same for all of them. So then when we move to the next one, we'll get this one, and so on. I wonder if we're just going to leave it like this and see if it works. Oh, also, plus 1, plus 2, plus 3, 4, 5, 6, 7, 8, 9, 10, 11. So we do 12 vertices. So at the end of this, we want to do triangle index plus equals to 12. Okay. It feels to me more and more that you're creating your own engine inside Unity engine, like starting with some manual circle drawing algorithm. In some ways, I agree with you. Okay, do we want to take this for a run? Maybe we do. Let's try it. Last of all, we also want to do... We have vertices, triangles. Dino custom physics next. That is something I've tried to avoid as much as I can. But I know it's a joke, but we're probably going to do some minor physics calculation ourselves later on if we want to do some real optimization. It's basically related to the terrain. We're having a height map that forms the terrain. Right now we have a mesh collider solution which is very unoptimized. If we want to go perfection, we're gonna have to implement our height map collision detection ourselves. But yeah, another day. Yeah. Let's see, what do we want to do here? We want to do mesh.vertices is equal to vertices, and mesh.triangles is equal to triangles. We probably want to set something else later on, but UVs and normals, we can wait with those. We don't want to do set indices like this this time around. Okay, let's try this. Outer vertex start index. We don't really need this one, but yeah, let's try it. Dino, maybe I could interest you in some networking as well. Something along words massive and multiplayer. I've been very clear that this is initially just going to be a single player game. So that's where I'm going to have to stop you. Just because I don't want to do any networking stuff. Tessellation, mesh creation. Let's go with materials, MISC, or prototype, opaque, prototype gray material. Don't we have... Actually, we can just go with this one, I think. Dimension, let's go with 10, 10, and we do 1 subdivision. Okay, if it crashes now, if the stream crashes now, I think it shouldn't. I just want to say thank you for watching. So MMO it is, confirmed. Okay, index out of bounds. Some indices are referencing out of bounds vertices. Index count 48, vertex count 13. Vertex count 13. We did subdivision amount 1. Let's go through this. 1, we do 2 to the power of 1, results in 2. So generate mesh. This one is 2 here. Vertices, we do outer vertex count, so that's 3. 3 times 3, 9, plus inner vertex count, which is subdivision, which is 2. So this is 4. 9 plus 4, 13. 13. And that's what we want, right? 1, 2, 3, 9, 13. So index count 48. Down here. So the culprit is probably this one. What do we get? J. We can get 1 here, so we get 2 times outer vertex count, which is 3. So we get 6. Okay, is it this one? What's up, Sightsand? Well, there are a lot of simple multiplayer games that streamers like to play. Oh, yeah. I think the keyword is simple together with single devs in most cases. And I don't know, simple sounds a little bit degrading. I don't mean it in that way at all. I just mean it like constrained, maybe. Or, yeah. Okay, so the problem is, what we want to find here is, where the hell do we get index count 48? Worst case scenario, J plus, it has to be this one. Inner vertex start index, outer vertex count 9. 9. E. We might fuck it up here. Or actually, are we? I don't think so. 48. Two times outer vertex count is 9. Yeah, here we get 18. No, we don't. This one is 3. We get 6. It's definitely not one of these. Am I blind? I and J never becomes bigger than 2. So they are just 0 or 1. At most we can get 2 here and 2 here. Hmm. One sec. Do we have 81, 81, 81, 81? Yeah, we get this one. Debug.log, size of array, current index. Yeah. But like, we're probably gonna have to rely on something like that because it solves, or it solves it for me as well most of the time. But we have a pretty great message here already. Failed settings triangles. Vertex count 13. So that means that our vertices, it has the correct size. It's just that one of our triangles points at index 48. So the right hand side of one of these is 48, which I'm not seeing at all, but Unless this one is extremely much bigger than it should be. But I don't see that either. Subdivision. This one I can see. Oh. Jesus. We want to do... Nah, fuck, do we want to do it here? This one becomes 48. 2 times 2, 4 times 4, 16, 32, 48. Yeah, we're probably gonna have to do some debug log here, but I don't see it. Where could we put it to help us? 2, 4, 16, 32, 48. We do 0, 1, 0, 1, so we get triangle index 12, 12, 24, 36, 48, but then we don't do anything else. Okay, if we want to debug this, where do we want to put the debug? Is my question. Index count 48, vertex count 13. It could actually be, let's see here. Okay, 13, 2 times 3, 6. Plus 2. And this one should be 8 at the most. But, okay, inner vertex start index 9 plus 6. Okay, this is the problem we have. This. So this is 9 plus... No, plus 3, which gives us 12, plus 1, which gives us 13. So if I and j are 1, this one fails. Okay. Because we want to do inner vertex count here. Inner vertex count, subdivision. I'm pretty sure this is the problem. I sure as hell hope this is the problem. Oh my god. That is beautiful. The only problem being that the middle point is fucked, but we can solve that. I always want my origo to be in the middle of my generated meshes, so we're gonna solve that. Yeah, let's solve that first, and then let's try and subdivide it once more. I also want to try and test to do subdivision amount 0. So we just get one of these, okay? So first I want to try and offset it. We can do that here. By doing... I guess we could just do it by vector 2 offset is equal to new vector 2, and here we do minus 0.5 f times dimension x minus 0.5 f times dimension dot y. And we do offset, so we do plus offset dot x plus offset dot y. And same thing here, plus offset dot x y. I think. Now give them a body and gravity so they would fall. Not yet. It would be hard to debug as well if they were just falling from us. But okay, this is nice. This is perfect. Okay, let's try it with subdivision amount 0. Beautiful. Let's try it with subdivision 4. Hope we don't crash. Okay, great. Okay, beautiful. Do we have... Yeah, we have backface culling as well. Okay, great. Oh, this is beautiful. Arcanum WoW had a 5-second long ad. Damn. That's a real short one. One sec. I'm just gonna double check. Okay. Yeah, makes me wonder what that ad actually was about. Very nice job if they successfully make you want to buy something in 5 seconds. Okay, this is beautiful. So the next step, what we're going to do next here is that we're going to implement our own shader. We're going to start by a simple vertex and fragment shader that just colors this one in a pure color. And then we're going to add tessellation to it. The way I want to do it is, yeah, I think we're going to take one of the snow shaders and simplify it. I actually have no idea. I did not pay attention, so they failed pretty hard. Okay, so improvements can be made. Okay, so let's do this. Environment, terrain, and not here. I want to go to shaders, environment shaders. Terrain procedural snow. Yeah, let's simplify this one. Terrain tessellation test. Let's see what we have. Terrain tessellation test. I want to leave backface tolerance, view custom tolerance, max distance, max amount. We're going to simplify it a bit here. We're going to do tessellation amount. We don't care about lighting for now. I want color, however. Opaque, universal pipeline. Fuck geometry. We can leave these flags. Skip that one. We're gonna do, we don't want geometry. Hull domain fragment vertex. Yes. I think we're gonna remove these for now. We're gonna do very simple here. Vertex shader input, position world space. Position world space. Pretty sure this is object space. Pretty sure this is object space. We're gonna skip normal and tangent for now. We're gonna skip UV for now. Position, vertex shader output. And here we're gonna do position world space. No, we want position world space and position clip space. We're gonna skip these. We're just gonna make it as simple, bare bones as possible. Edge, here we do 3. Inside, I think we can leave it like this. We don't care about progress or max progress. Domain shader output, position CS, that's pretty much everything we want. Geometry shader, joink. We're going back to the basics here. Mesh grid delta, don't care. Don't care. Get vertex position inputs, OS, world space, clip space. Oh, what is the... I wonder if it's just try. 3. This one we're gonna have to work with. Looks all right. Okay. 3. View vector. Normal, so interpolate. interpolate barycentric. Okay, interpolate barycentric, I think it is. Here we need the damn normal. Load 3. Yeah, we're gonna need the normal, yes. So I was a bit too... Our normal, however, is probably only gonna be... We can do it like this, actually. Normal OS, normal. Sighton, is there a reason you did the subdivision outside the shader? So you mean why we, instead of doing any subdivision on when we generate the initial mesh, we just give it down as one big quad pretty much, or 4 triangles to the shader, and then we do all the tessellation on the shader. That's mainly because you have a maximum amount, a maximum tessellation amount you can make, hardware based, or it's probably implementation based in DirectX, but it's pretty much, we want to allow for even more tessellation than that, probably. So if we would send down, in our use case eventually, we might generate a mesh on the CPU that is 50 times 50 meters. And if we would send that down and then tessellate it, we would probably just be able to tessellate it. So we have, I don't know what it is, 32 times 32 quads, which means that each quad would be quite big in world units. So it's just to be able to get even finer resolution on the part of the mesh that is close to the camera. Hope that makes sense. I think we have tessellation max. Don't we have any max? Yeah, it basically has to do with the maximum amount we can set. Where do we have it? The maximum amount we can set output. So the maximum amount we can subdivide each edge. Okay, so what do we have? Should backface cull to interpolate barycentric. Should out of Frostum Cull we have a 3, 0, 1, 2. Oh, when we did this as quads, I didn't even take all the 4 points into account. Oh well. 3. Calculate tessellation amount. Bam. Hull patch constant. We take a patch of 3. We take triangles. Interpolate. Very centric. $1.3. Should backface cull? If so, we set all of them to 0. And then here, I just want to do, if we get to this point, so that means during the tessellation, we're not gonna frostum cull or backface cull the triangle. We want to subdivide it. In this case, we're gonna do is equal to tessellation amount. But here I want to do pow to tessellation amount. Actually, no. While we're experimenting, I want this one to be like this, I think. And we might actually want the inside to be tessellated more. We will experiment a lot here, so let's keep it like this. Domain triangle. Actually, let's double check. Do we have a nice example? Look at this tessellation. Fucking beautiful. Oh, I know. HLSL tessellation shader. I know. That we should have. There should exist how to create a hull shader. How to design a hull shader. Quad can a domain attribute. There we go. Try. We have factors, we have a patch of 3, and this one is not UV this time around. This one is 3, and I don't remember what they usually call it. Barycentrics. Actually, I just remembered. We do this type of tessellation. Domain try. And we do pow2 try here as well. Good, try. And then we do barycentric. We can domain location. Okay, we can probably call it whatever we want, but let's go with barycentric coordinates. Position VS, barycentric coordinates. Interpolate by linear. I think we want to change all of these to interpolate barycentric. Remove this, this, and this. And for now, we're also going to do this. Centric. Geometry shader. And then lastly, we have fragment. For now, in here, we're just gonna do color. Okay. Very nice, basic terrain tessellation test shader. Let's tangent VS. Do I actually... Okay, maybe we skipped this one earlier. UV. Position VS. Invalid subscript, position VS. Is it actually here though? Mm-hmm. And yeah, we don't have normal either. This one we can do like this for now. Geometry shader output, yes, because we want to do the main shader output here. Patch constant function must use the same input control point type declared in the control point phase. What seems to be the problem? There we go. Okay, no compiler issues. So let's do materials, environment. Let's just create it here. Terrain tessellation test material. Environment, terrain tessellation test, color. Yeah, we can go with white. And then we set this one here. Okay, let's see if it crashes. Okay, it doesn't crash, but okay, we get some wrongful culling like this. We don't cull the backside. We have it here. So what do we have? I guess we can just up this tolerance to 1 and 100. 0. Okay, we don't have any normal, so we can't rely on backface column, but that's okay. Okay, so now let's see what happens when we start tessellating this one. Actually, we have tessellation 1. 0. Okay. Yeah. This, although pretty, this is not what I want to see. I'm wondering if... Actually, let's generate this one with a subdivision of 1. So we can properly, or better, see exactly what's happening. So this is our original one. If we tessellate once more, we get... So look at this. We tessellate each edge once. So we get 1 point here, 1 point here, and 1 point here. We only tessellate the inside once as well, so we get this point. What I want to see is... I want to see this. So I guess we want to tessellate the inside once more. Let's try it. We're also gonna experiment with this one quite a lot as well. But let's just do tessellation amount, and here we go, tessellation amount plus 1. Which leaves us with this. Okay. Yeah, we always tessellate the inside, so we get... This triangle gets... if we have 1 here, we get 0 on these, I reckon. But we get 1 here. That's not what we want to see. Okay. So when it gets to, let's see, partitioning, I think this one is what we want to rely on the most. Domain partitioning. I never seem to be able to learn these, but we do integer, fractional even, fractional odd, POUT 2. This is integer. This is POUT 2. And what do we get if we do... let's see here. HLSL, tessellation. I want to write Triforce. Yeah. Actually, let's go back to this one real quick. What I want to see is we want to go and if I understand it correctly, oh, fuck, did I screw it up? Side 1, I want to split it in the middle. This one in middle, this one in middle. But how the hell do we handle the center? Is it actually 1, 2, 3, 4? Integer. Ah, that's chaos. If I've ever seen it. And we're gonna do partitioning examples. Don't we have? Starting to think this is wonder if this is the first roadblock. Heuristics, edge length. This is what this example here, tessellation example. Harukanan, don't you just want to split the hypotenuse on each subdivision? We want to split so we have these triangles. We don't have 90-degree corners. If we would have this triangle, we would want to split the hypo. But if we have these triangles, we want to split all of these once, and then we want a triangle here in the middle. We want to split each triangle into 4 triangles. Wonder if that's possible. Which is 1, 1, 1. We pretty much want to do it exactly as this nice example in the HLSL documentation. That's beautiful. This example we have right here, it's just which makes me think if we want to do tessellation amount 0 on inside, but it's triangle tessellations. If we do +1, we get something. So in every other, so I guess 1 in 2, 4, 8, 16, we start to get something that looks like something we can use. I would say which makes me want to do we do L2. And if we try partitioning fractional even, Jesus. Honestly, this is one way to solve the popping issue. If we do, and we just fade this one, the closer we get. It's gonna be fucked up when we go. We're gonna get some seams we don't want to. Yeah, maybe. We're probably gonna get some seams that are not preferable. Starting to think that the example right here is not possible. Or I haven't given up, but need more understanding about this. Per edge. Inside in this case. We split each edge here once. I mean, we... Problem in this case is that we always get split into the middle as well. And avoid this. Yo, what's up, Diligence? And that's some crazy polygon patterns. Yes, indeed it is. We're still on tessellation. I'm trying to get some knowledge here. I'm trying to control this as good as I can. I want to have... I do so want to have a Triforce pattern here. Is it better looking or optimized instead of just pure triangles? Not entirely sure I know what you mean, but basically we're experimenting with having this topology as a base mesh and want to try and get to the bottom of if we can tessellate this in a controllable way. So for each tessellation stage like this, if we could control it so we get Triforce pattern instead. Harukanan, you cannot get even-edged triangle from a quad, I don't think, at least. Probably not. So what we have here are 4 triangles. We build this mesh up as if it was 4 triangles. And when we subdivide one of these triangles, we want them to result in 4 new triangles. Like so. We want it to triangulate exactly like this. Like this example is beautiful. Diligence, is it to make snow deformation look better? Yeah, it's to make our terrain look better, our water look better, our snow look better. Not only look better actually, but also optimized. I mean, one sec. We could probably... Yes. Ooh. Ooh, we can probably control it. I wonder if this part... Hmm. Hmm. No, 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 no. I wonder... See, 1, 2, 3, 4. we should be able to arrive at something like this. I hope. Fractional odd, fractional even. I mean, we could probably... Like, I could possibly imagine a solution where we fix the popping by having a very dynamic tessellation amount. But it's also like the end pattern here. Hate this. I think this is as close as useless as we can get. I thought we had an optimal... thought we gave it an optimal mesh here for tessellation. Oh. I'm gonna have to deep dive, what is the word? Deep dive into exactly how these portionings are working. And maybe, I'm still trying to be optimistic, we can get to the bottom of it. Reself, what up? Your shader seems pretty impressive, to be honest. Have you a good resource to get started with that kind of stuff? Yes, I do. Send me a PM on Twitch or on my Discord, and I can give you some resources. Because unfortunately, I have to run now, but tomorrow we will continue with this. I'm not giving up on the control over the tessellation just yet. I think we have at least some knowledge, some more knowledge to gain here. But yeah, I gotta run. Thank you for watching. Hopefully I will see you tomorrow when we continue this madness. Have a great rest of the day. Peace.